If we're all ready, I'm happy to introduce Mr. Stephen Munro, who'll talk us through probabilistic demand risk. Over to you, Stephen.
Thank you. Good afternoon, everyone. I'm Stephen Munro. Thanks for joining the session. It's nice to see some interest in it. I'm an innovation development engineer at the moment. I have been for 12 months in the innovation team at SSEN Transmission. Prior to that, I was a power system engineer in the outage planning team in our control room for about 9 years. And prior to that, I was an outage planning engineer at the National Grid ESO control room. So lots of outage planning experience and lots of experience of having conversations about demand at risk over the years. So today, I'm hoping to talk to you about an alternative view of demand at risk and combine that experience with my innovation experience for the past 12 months. So just to give you some context around the problem, consumers consistently rate reliability of supply as their top priority, and we know that from our stakeholder feedback. That's a consistent message that we get. So naturally, it follows that TOs and DNOs are encouraged to ensure that their respective networks remain reliable, and that includes during planned outage activities. The mechanism for encouraging or incentivising the networks, there's a TO sort of specific one, which is energy not supplied, or ENS, and then there's the DNO version of that, which is the Interruption Incentive Scheme, IIS. And just to be clear, for avoidance of doubt, because this has come up in another conversation, when I talk about an outage on the transmission system, that doesn't usually involve disconnecting any customers. It's a mesh network, therefore we can de-energise part of it and the power flow finds another route. So generally when we take an outage on the transmission network, nobody's lights go off. So it's just to be clear that's the context that we're talking about. It does it, or it can introduce risk to demand, and that's what we're talking about today. So in terms of the volume of demand, we tend to talk about that in terms of megawatts, but the duration of any customer interruption or period of risk to demand is a critical factor in the ENS and IIS calculations. And this is why the emergency return to service time is a really key element of any planned outage. So just to explain the ERTS, if anyone's not familiar with that, that's the time that it should take for work to be stopped on the asset, safety to be removed, and then the asset to be re-energised in an organised fashion. So all of this is sensible and logical in the interests of a reliable network, but what I'm bringing to the fore today is that there's increasingly a conflict between this careful mitigation and a given network's commitment to what is an unprecedented level of reinforcement that we need to deliver at, I would say, unprecedented pace. There is a broad measure of that at SSEN Transmission, which is that we need to deliver twice as much in half the time over the next 5 years. So it's a massive challenge on its own. So stepping back a little bit from that detail, experience tells us that circuits and other assets on a planned outage very rarely actually get recalled back into service under that emergency situation. The worst fault, which would cause the demand to be disconnected, very rarely occurs. And the process of negotiating the ERTS between TO, DNO and ESO, it's a collaborative process, but it's often very long and repetitive. And that's fundamentally due to the conflicting drivers of each party involved. In the background of all this, again, experience tells us there can often be a trade-off between the ERTS time and the planned outage duration. That is to say, a lower emergency return to service time can often cause an outage duration to be extended. So you're trading off one risk for another, arguably. No, I've been on the wrong slide all this time. There we go. Apologies for that. So what I'd like to see coming out of this is a solution that considers data about the TNO and the DNO asset status and health condition, the resource available for the DNOs and the TOs to implement any kind of emergency return to service solution. I'm thinking in terms of switching resource primarily. Any methods that are currently used, for example, some DNOs use auto-switching, but also to be cognizant of the impact of the worst fault occurring in terms of the number of customers, which can be quite wide-ranging across different parts of GB. And all of this I'd like to see combined to ultimately quantify the level of risk of the worst fault occurring, and that I'd like that to be bespoke to each GSP, because each GSP, there's no such thing as a standard GSP. They're all nuanced on both sides of the ownership boundary. I think the solution would need to be collaborative, certainly, across both TO and DNOs, and include the ESO, primarily because my vision is that we would interrogate the data about the assets that belong to those network owners. But it would have to give us confidence that we could maintain the current ENS and IIS performances at respective networks. The benefit of this is that it could reduce the burden on projects to arrange extensive ERTS measures, and it could be a significant time saving for all parties involved in those lengthy negotiations that I mentioned earlier. So in summary, I'd like to see the solution that informs efficient demand risk mitigation for a planned outage, using existing data rather than, for example, applying monitoring that would take years to collect data and then identify trends before you could see any benefit. Something that can be used for a single GSP or multiple GSPs, depending on outage combinations, but will also not diminish asset life or increase network disruption beyond the main planned outage. And I think it's worth mentioning, just as a final thought, that there's always a risk of not taking action. This is a sensitive topic because of all the stakeholder feedback I mentioned at the beginning, but I'm keen to explore possible solutions to see if there is any kind of improvement we can make there to balance a little bit more risk with improved delivery of a very challenging portfolio. Thank you for your time. That's it.
Wonderful. Thank you so much, Stephen. We've got a few minutes. Are there any questions in the room?
Hey, Stephen, Richard here. I really like the overview. I think you've covered everything. But do you think that for the solution to be successful, it would need to be adopted consistently by each DNO or TO?
No, I think it could be adopted by individual TOs and DNOs. They would have to be paired, I think, the TO and DNO with the boundary. The ownership boundary would both need to adopt it for it to be successful. But I don't think everyone across GB would need to adopt it. Does that answer your question?
Yeah, I guess. something to look at later is a challenge of one company being more risk averse
Yes,
and being
absolutely.
more open to an outage at a particular time of year
Yeah,
versus another one.
definitely.
I think we're going with that.
There's a range of, I would say, types of relationship between TOs and DNOs across the GB industry. Some are closer than others.
Yeah.
And I don't think it's too controversial to say that we feel the pain of our relationship, which is where I think some of the benefit could come from this for all parties, including NESO.
Yeah.
Yeah.
Thank you.
Afternoon, Christopher from Advanced Infrastructure. I was a bit I don't yet understand whether you're seeking a solution to probabilistic demand or the probability of failure of the system. Could you clarify that?
I think it's probably the probability of failure. So the probability of a fault occurring that would cause demand to be disconnected.
And what are the principal causes of these faults, of these failures, sorry?
As I said, they're very rare on the transmission network, which is why we've got such a good ENS performance through VOT2. Generally, they are weather-based, so that would be a factor in terms of the time of year, storm season, that sort of thing. But there's also always a risk of an asset failure, given that we do have ageing infrastructure and we do have an asset replacement programme, but sometimes things go wrong before you maybe anticipated they would.
And finally, have you looked at the Credo Plus project run by UKPN, which is looking at the probabilistic approach to failure of substations?
No, that's good.
Yeah,
good
probably
point.
worth understanding where that falls short of your aims.
Sure. Okay, thanks.
And just to say, Credo is one of our CIF projects, and it's done an excellent report recently. So yeah, would recommend anybody read that, as the gentleman pointed out.
Thank you.
Thanks, Stephen. Tom Storr from ERM. I'm just sort of thinking about implementation sort of a little bit. And I guess, so first question is, if we imagine that we're sort of basically developing a model in some broad sense, then could you sort of talk a little bit about what data is available to sort of train or calibrate that model?
Yeah.
As you say, they're very rare events. And then secondly, are you imagining something that's kind of ingesting like, you know, long-term climatology, like flooding risk kind of data set, or more kind of like 7-day weather forecasts? Like, you know, I'm just sort of trying to think about on what sort of, you know, what the kind of timeframes are we looking at, strategic risk or operational?
That's a good question. I think probably 7 days would be too short because these ERTS plans take a long time to arrange and agree. So it's probably not the answer you want. It was probably somewhere in the middle. Sort of 12 months, I suppose, ideally, 12 months ahead.
And in terms of the training data?
In terms of what, sorry?
In terms of the training data, so under what circumstances are there network failures, and then mapping those?
Sure. So I guess in terms, it depends on the asset really, but we have a maintenance and inspection regime for all our transmission assets, and I'm sure distribution networks have the same arrangement. So I would anticipate drawing out that sort of data to give that more bespoke, granular view of the specific assets at a particular GSP, rather than just the sort of mean time to failure for any 33 kV cable, for example, which doesn't really tell you much about that particular GSP.
Hi, Joe Weston from DNB. Just wondering about the kind of what are the KPIs for success of this tool? Is it reduced time to agree the ERTS and possibly outage duration? Are there any others?
Yeah, I would say so. It'd probably be hard to measure, but it would be nice if we could confirm that we've improved the program, a project delivery program, or at least minimised any extension, depending on how you want to look at it. But yeah, those two would be the fundamental ones. Yeah.
Okay. And one kind of follow-up question. Is there maybe some potential for like looking at this through the incentives and the policies around that? I mean, obviously you wouldn't want to kind of dilute the protection
Yes.
of consumers against losses of supply, but maybe there's like a policy angle to that as well.
Yeah, no, I think you're right. I'd been thinking more of a technical side, but yeah, I think that's valid. As I said, it's politically very sensitive, given the stakeholder feedback is very consistent on it, but it doesn't mean it's not worth looking at. Yeah.
Okay, thank you.
We have time for a last question. So I think he was first. We have a Q&A session afterwards.
Sam Young from Edge Systems Catapult. How would you see this as integrating with the monetized risk framework that SSEN has, which I think already does probabilities of failure for kind of individual assets?
Good question. I'll admit that's not my area of expertise. I would have to take that away and come back to you on that one. It's a good question.
Okay, thanks. David McClellan from the EIC again. If I understand correctly, you're looking at the risk and probability of loss of the transmission network, the failure.
Yes.
And if I understand your previous answer to the first question, you're looking at that and not at the demand. But I'm wondering, could you consider it from the point of view of resilience? And looking at Jonathan's project and thinking of the JSP being self-islanding, self-supporting, which would then be taken into consideration within your ERTS.
That feels like maybe slightly larger scale. I was thinking my intention was to focus on individual GSPs, whereas I think Jonathan's could potentially involve a cluster of GSPs, a section of the network.
Sorry, cut across, but that could go down to GSP
it could
level,
do.
as Jonathan was talking about as well. It could go down to islands within the GSP as well at DSO, DNO level. And then build from the bottom back up to give you the resilience.
It could be an alternative approach to it. I suppose my assumption would be the solution to Jonathan's problem statement could take longer to develop than maybe a simpler solution for this. Maybe not. So open to any ideas, different approaches. Okay, thank you everyone.